Ciao, buongiorno. That's all my Italian. Thank you, Duolingo. And io mangio na mela. Yeah. Today I'll talk to you about instrumenting Go apps with OpenTelemetry. My name is Alexandre Cabral. I'm from Brazil, but you can call me Mago also. It's on the shirt. I'm a senior software engineer at Stone. It's a fintech company in Brazil. So first of all, the most important slide about my cat. Her name is Genevieve, aka Gigi. She's 3 years old and Brazilian from Minas Gerais also. And about me, I had a automation company in Brazil, but I broke. I worked for companies in Germany, USA, and Brazil also. I'm a community organizer in Brazil at Tech Hub JF. If you want to give a talk there, if you want to go there and visit us, you are all welcome. And I work at Stone. It's in a self-service platform and chatbot there. First of all, I'd like to talk a little bit about observability and what is it. So we heard about telemetry from Russ Cox. So you may be thinking, can he talk after Russ Cox? Let's see. I like to think we're soulmates, that we thought about the same thing. So telemetry, monitoring, and observability are three things about the same stuff, but a little bit different. Telemetry is the act of collect and transmit data. This data can be metrics, measurements about your system, CPU, memory usage, things like this. You can have logs. There are texts about your system. It can be info, errors, things like this. And usually we talk about structured logs. We use them as JSON form. And we have the traces. There are information about your requests, usually, but it can be, if you have a cron job, it's about your process. You can use it on other situations also. Monitoring is the actual individual data analysis. When you pick one of these and you analyze it, you can see like a symptom about your system to detect an issue. Observability is something more about multiple data types at the same time when you are trying to do an investigation. And usually is very important for distributed systems. So you can find out real root causes, not only the symptoms, but the root cause of a problem. You can improve performance of your system, and it brings more reliability. And all of this, Russ Cox brought us some information about this. And some tools we have Prometheus, for example, for monitoring, but it's more about metrics, it's about one type of data, and Datadog, it's an example. But I'm not being paid by Datadog, but if there's someone from Datadog and wants to pay me, that's fine. And Datadog, it's an example of observability tool. And let's start with a story, okay? So let's think that you want a beautiful dashboard so you can see all your metrics and show your stakeholders and say that you were awesome. You have to instrument your application first. To instrument it, you need to use a library from the vendor. In this instance is Datadog. So you use it inside your backend. Depending on the language, it will be an auto instrumentation, just import and that's fine, and you have your data being sent already. Or you may need to do a manual instrumentation. And after this, it will send information for your Datadog agent, but each vendor has its own agent. And this agent will process this data, filter, and send it to the real backend that will have this information to be shown on the dashboards, okay? In this example, I'm showing as a sidecar inside the same pod, but you can run this agent separately, okay? But let's say one day your CTO says, no, Datadog is too expensive. We may think we need to think about a cheaper option, and maybe New Relic is a cheaper option. I'm saying that this is just for illustration because I don't know the price of each one, okay? So you have to do it all over again, yeah. So the solution is you quit. That's right, because you don't have to be instrumenting everything all over again. No, but the real solution is OpenTelemetry. Yeah, it's magic. And what is it? It's more than telemetry. It's a framework, okay? It's a specification, a protocol, a combination of APIs, SDKs, tools, and a collector that's written in, exactly, GoLang, yeah. And the advantages is that OpenTelemetry is vendor neutral, so it doesn't depend on one vendor. You instrument once, and that's all. So it means less rework because you don't need to re-instrument every time your CTO wants to pay cheaper products. And it's open source, yeah. Even it's inside the Cloud Native Computing Foundation, that's a branch from the Linux Foundation, right? And you have many projects inside that are famous. Argo CD, Containerd, Istio, Jaeger, Helm, and many of them are written in Go, yeah. DevOps and infrastructure loves Golang. OpenTelemetry is the same idea. You have your code instrumented with some libraries, SDKs, APIs, and you start sending OpenTelemetry protocol to your collector. That's the same idea of the agent, or you can send it directly to the vendor itself. You don't need to pass through the collector, but it's good because it will bring more transparency for the developer. The developer doesn't need to think about where the data is going. He just sends to the collector, and the platform, foundation, team, doesn't matter the name, will choose where it goes after. And the collector accepts not only OpenTelemetry protocol and not only exports OpenTelemetry protocol, it accepts other protocols. So this way you can do a gradual migration of your systems to send information to the collector, because some teams, they have more time to spend with this. Some teams have to deliver features faster, so they won't have time to sending the OpenTelemetry protocol instrument, but they can already send to the collector. And you can export for more than one vendor at the same time. You can send to Datadog and New Relic and more than once. And also you have some process inside the collector. Usually we use it to sample this data, and Russ Cox talked about it. Sampling is very important, especially when you think about companies that has lots of data. You have to sample your data because it costs. It's the first thing when you have lots of data. And also, it's not good because you have to filter all this data. It's harder to find it's really important to you to find about bugs that's happening in your system or to improve performance. So sometimes you don't need to send all the data, all the traces that were okay, all the okay status. Maybe you just want the error status. It's more important. And let's talk about Golang. Each language has its own page on OpenTelemetry website, and it has information about the status of the traces, metrics, and logs, how they work in this language. And for Golang, we have traces and metrics stable, and logs is still in beta, but you can already test it. We have already some kind of automatic instrumentation for Golang, but it's still in alpha. So you can try, but don't use it in production, please. Today, I'll show you an example about trace instrumentation, okay? So let's start with what is trace. Trace is a collection of spans. Span is the real information that you have about your request, for example. And you have the root span, and below you have child spans. There are informations about other parts that's happening inside your requests. It can be when you connect to your database and you do some query, or when you connect to a client, when you call a cache, things like this. You can create one span for it or many others. So to start, you need to import some libraries, some packages from OpenTelemetry official repository. There are just a few, okay? And this is basic instrumentation. And this is an example, just a suggestion on how to do it. This telemetry package is the one that I created. It's not a package from OpenTelemetry. But you start your OpenTelemetry. Then it's important for you to inject the tracer you create inside this function, inside your context. Because when you create a new request, when you receive a new request, thank you. When you receive a new request, you have to create a new trace every time, right? So you need the tracer inside your context, so you pass along your base context on your server. So you start creating a resource. Resource is information about the system that's generating this data. So it will be attached to all the information you create. So you can have any information that's important to you, KS container name, pod name, or all this stuff. And then you created the exporter. That's what will really connect to the collector, that will talk to the collector. You pass the endpoint, You can use it insecure if it's in the same network, right? In the same Kubernetes, sorry, my English. And you can set a timeout because sometimes maybe the collector is down and you don't need this information, so you drop it, okay? And you start a provider. The provider is the tracer factory. It's what creates the tracers. Sorry, my Italian. And you start with a batcher because you collect data, but you don't send it each span at a time. You collect more than one span, and then you send in batches. And you attach the resource, and you start with a sampler. The one that I talked before in the OpenTelemetry protocol, the sampling that happened there, it's called tail sampling. It's a more intelligent sampling that's based on maybe the status of the trace. And this one is a more stupid one, but a faster one because you don't want to spend process of your application to do the sampling. So it's parent-based. It means it will check the span and see the parent of this span. If it was sampled, it will sample the child. And it goes on until the root span. When it reaches the root span, it will do the trace ID ratio based. It means basically it does some math with the ID of the trace and try to reach a percentage of sampling. So if you set 20%, you try to sample 20% of your traces. The parent based is very important because you don't want like broken information. Maybe you send just the span of the database, but you don't send the request itself. So the parent based makes it like the whole trace will be sent, okay? And another important thing is the propagator. The propagator is what really makes the distributed tracing happen. It basically, when you think about REST, it will inject as a header information about the ID of the application that's requesting another application, okay? So we will have a header called trace parent. If it's gRPC, you have in the metadata, not on the header. And this information will reach the other application you're calling, and they can handle it and inject in the trace data, and it connects on the dashboards, okay? And you have the GoContrib. This repository is a third-party packages that's not about the specification of OpenTelemetry, but it's tools that make developer lives easier, okay? An example that we use in our company is OTel HTTP, where we create a middleware that every request will pass through it, and it will handle the creation of the trace for us and the end of this trace also, and it will handle also the propagator. It will extract information from the propagator, these headers that I talked to you, and it will inject on our traces for us. We don't have to do it manually, okay? And on the handler, you just have to get the span from the context, and then you set an error if something goes wrong on your request, or you set a OK code, and at the end, you just set the status of the span. You can create a span anytime you want, wherever you want. For example, on a client that we are calling, you can get the tracer, start a new span with a name you want and a kind, and then you just have to call a defer span end, so it goes all good. And on Datadog, you have information about the traces you created, right? You have information about something that went wrong. Thank you. You have information about something that went wrong will be red, and the green ones will be the ones that got okay. And you have information about the whole thing when you do a proper distributed tracing instrumentation. In this example, we have a SQS client. It's not a request itself. We are processing some messages from SQS. We're calling a client, a chatbot, and we have information about the chatbot info in the same graph we have here, in this flame graph. And we have information about the database we called, the client from Twilio we called. So we have the whole data here in the same page. And if something goes wrong, you have information about the error itself. You have here all the trace of this error that's happened. And like I said, you can have the same information that you had on Datadog. You can send it to other vendors and other providers. In this example, we have Grafana with Tempo. and you have the same information you had on Datadog. So maybe it's important because some things, they are more used to Grafana, so they can find information faster on this tool. Maybe you have hosted on your company, so you can have both. You don't have to choose one, just one of them. You instrument once, and that's it. So OpenTelemetry, in a nutshell, is about money and about time, because it means less money your company spends and less time you spend, because, like I said, you instrument once and you can be happy forever, right? And that's it. Thank you. And these are my social media, okay? We have the QR code if you want to reach me. And I didn't think we had time for questions, but if you have questions, just raise your hands or something like this. And I'll be at the conference, so if you want to reach me, just if you see me with my shirt, you can call me, okay?
Any question?
Okay, here.
Yeah.
How hard do you recommend?
Wait. How hard would you say it is for a company that has absolutely no telemetry to get to the point where they have decent information, switching to OpenTelemetry? Like adoption cost, are we talking about like few weeks, few months, few years, 20 minutes? Like how would you say it's hard to adopt this in a Go project?
Okay. If we talk just about the instrumentation itself, okay, it's pretty fast, and it's similar to any other vendor you want to instrument with, okay? Maybe you have options about auto-instrumentation. Actually, I don't like auto-instrumentation, automatic instrumentation, because maybe you are sending too much information or information you don't need, but it's always better information than no information, right? So you can start with it. About the adoption of OpenTelemetry is something about maybe a week. You can instrument your application and start sending. Of course, you have to learn about the vendor itself you are sending this information. So there's this cost also, but it's pretty straightforward. There's no problem. And inside the OpenTelemetry website, you have all the instructions on how to instrument on each application, on each language. So Golang, JS, all this stuff.
Okay, thanks.
What are your questions? Anyone? Questions?
Okay.
No? Okay.
So I'd like to do a giveaway. Since you asked the question, you will win. I will throw away and see you guys killing yourselves to get the golfer, but I think it would be easier this way. And just remember, this is the golfer from the GopherCon Brazil. Okay, it's a event that happens in Brazil. Nowadays, it's called GopherCon Latam because it's the bigger Latin America GopherCon that happens. And you are all invited. It will happen this May next year. And there will be presentations in English, Spanish, and Portuguese there. It will be more international. So if you want to go, you are all welcome there, okay? Maybe I will be speaking there. I don't know. I submitted, so let's see. And here for you. And that's it. Thank you, guys.